Hey everybody, this is Erin from Erin's Audio Corner, and today I'm going to be looking at the Perlisten S4b Bookshelf or Surround speaker. Now this speaker was loaned to me by the owner, FOMO, so shout out to FOMO. And I will say that I had to pay shipping both ways for this, so if you're interested in helping out, I do have a Patreon. It's patreon.com/Erin's Audio Corner. That would be cool. Enough of the cheap plugs though, let's go ahead and take a look at this speaker. Now the speaker retails for $8,000 per pair, and it is just I don't know, it's a really interesting speaker. If you look at the front of it, you can see it's got the wave-guided tweeter, and then it's got an arrayed mid-range set, and we'll talk about that a little bit later. Then it has the woofer down here. It's a, I think, 6.5 or 7-inch woofer. You can see I've got the, excuse me, piano gloss black finish, and then we'll spin it around the back, and you can see that you can buy wire this speaker. And it comes with little terminals. You can pop these off if you want to do that. Otherwise, you just use this link to single amplify it. This speaker has the Dominus rating from THX, and that can mean different things for different speakers. THX doesn't provide the public their standards or their specifications for how one company can achieve such a rating, either Dominus or THX Ultra. There's a couple different ratings that THX offers. So I don't necessarily know what allows this speaker to have that Dominus rating, but I will say that the specification from the manufacturer implies a very high output capability. When listening to this speaker, I didn't really have any issues with it getting loud, but I will say also that when I was listening to it without a crossover, the bass on Dire Straits' Money for Nothing would cause the woofer to meet excursion limits at about 100 dB at about 3.5 meters away. Even though it is a very large bookshelf speaker, it does not go much lower than about 80 hertz in room. I think its F3 is actually around 78 or so hertz. It is a sealed alignment, so there's no port, and it starts to roll off at around 100 hertz. And when it starts to roll off, it rolls off at that standard of 12 dB per octave rate for a sealed alignment. Now, that's a double-edged coin depending on how you look at it. In one aspect, it's great because it makes it easier to set up with a subwoofer, and this speaker absolutely does need a subwoofer. Also in that same vein, you just really can't whomp on it too hard. So if you're doing what I was doing and trying to use this as a full-range speaker for evaluation purposes, that's not what it's intended for. And that's not to say, I wasn't using it as it was intended. I was just trying to see what it's capable of when ran full range. I did throw an 80 hertz crossover on it, just the LR24 electrical crossover, and ran this sucker up to pretty significant volumes. And in that regard, there's no issue with output. The compression testing that I did and the distortion testing that I did, and we'll talk about that a little bit later, all show a superb speaker. But again, that's going to be band limited from about 100 hertz and up. If you're like me, you're probably thinking, okay, you expect me to pay $8,000 for a bookshelf speaker that doesn't really go much below 100 hertz. Yeah, that's kind of it. What you're paying for is not so much low frequency output, but it's overall build quality and a really high degree of engineering in regards to dispersion and directivity. And what do I mean? We're going to talk about this as well in the data, but I can tell you up front that the directivity index data, which means the off-axis radiation pattern relative to the on-axis radiation pattern, is nice. And matter of fact, it may be the best that I've seen so far from any speaker, period. The vertical directivity is really, really interesting. And that's due in large part to the mid-range waveguide assembly, which you can see here. Now, what do we got here? Well, we've got a mid-range, and then we've got a tweeter. And the way that this setup works is to basically beam steer the sound out in front. Now, why is that interesting or why is that good? Well, I can tell you what I heard and why I think that matches up to the design of the speaker. And when I was listening to my music, many times I would be hearing things in the mid-range, just really significant details. I won't say subtle, but they're pretty significant actually, where I thought, well, that's interesting. I've not heard that before. One case in point is Matchbox 20's Real World. I'm a big Matchbox 20 fan, by the way. There is the snare, and when the snare hits in the song, you can hear reverb off the back wall, or what it sounds like it's on a back wall in the recording at least. And I thought, well, that's interesting. So let me hear that again. And I played it again, and I thought, well, I've not heard that before. let me go get some other speakers. And I keep, different speakers on hand, rotating throughout for my reviews. I also listen on my headphones. And while I heard that effect, probably more so now because I was listening for it, it wasn't as distinct. And that to me was really, really neat. And for that reason, I would say that that's why you need to listen to these speakers. I mean, you're probably going to balk at the price. Most people will. I know I certainly did. But I say give them a shot and listen to them for that reason alone, because you may be impressed enough just by that you're like, yeah, dude, I want those speakers. Same goes for the other lines that they have, or the other models in this line, which would be the S7T, which is the floor standing speaker. And then I think it's the S5M. While I'm thinking about it, James Larson from Audioholics actually reviewed this speaker, and he reviewed the S7T. I'll throw up a link in the card above to where you can check out their discussion about the speaker. Now, James and I do differ in opinion on how much the low frequency matters. And again, I'm going to go back to that well of saying that $8,000 for a pair of speakers that isn't full range, that's crazy. That's hard for me to swallow. But at least the manufacturer tells us that it's not intended to do that, and they tell you that you need to run it with a subwoofer. So that's good. I mean, they're upfront about that. But just keep that in mind. Now, I've showed you the mid-range tweeter array. Let me show you what the inside of the cabinet looks like, and then we'll talk about the drivers a little bit more. But before I do that, let me go ahead and show you the grills. Personally, I'm not a fan of the grills. They really don't fit the overall aesthetic of the speaker. I think really that they're just designed for protection. So you would have them on if you've got little ones running around or you've got friends or family over. But if you're listening to the speaker, I would presume that you're going to take these off and not listen to them with the grills in place. All right, now you can see the cabinet, and I've taken the drivers out. You can see there's a whole bunch of polyfill type material in there. And you'll also notice the wires. Now the wires are pretty thick gauge. They're dual run wires. Nice gold quick slide connectors on them. And I even like that the shrink is labeled. They got the heat shrink label for the parts on there. So that's pretty cool. Now the crossovers are in there, and I'm not about to take those out because I just don't feel comfortable doing that. I'm sure the owner would be thrilled when he sees that I've taken all the drivers out. So shout out to FOMO. Don't pucker up too much. The enclosure is made from HDF. I believe it's 1 inch thick all around with a 2 inch thick front baffle attached to that. So a total of 3 inches of thickness on the front baffle. As I showed you before, you've got the mid-range tweeter waveguide assembly. And one thing I'll note is there's some kind of, I don't know exactly what it is, maybe resin, some kind of viscoelastic material on the back of this. I also noticed that there's viscoelastic material inside of the enclosure. So all of that tells me this exudes quality and designed function. It's not going to resonate. You're not going to have any issues with it. I'm not going to do the knuckle wrap test because that doesn't really tell me anything. But take my word for it. This thing is dense and it is well engineered to be a sturdy bookshelf speaker. Let's take a look at the midwoofer. Now, as I said before, this is either a 6.5 inch or 7. I'm not necessarily sure, but it really doesn't matter. The cone is Textreme material, and from what I'm told, because I made the same mistake initially, this is not made by SB Acoustics. I said that myself, but Textreme is the manufacturer of the cone, and they make a lot of products for not just audio, but also aerospace industry and other industries as well. So again, it's not something that is built by another build house. This is made by Perlisten in their own build house or factory or whatever you'd like to call it. I just thought it was worth noting that because, again, I made the same mistake. So let's go ahead and take a look at the data, and we'll kind of get a feel for what I heard and why I heard what I heard. And before I do, I will mention that all this data you're about to see was captured using Klippel's near field scanner, which is a robotic tool that will allow you to get anechoic data in a non-anechoic environment. And you can see here that the arm is moving around the speaker. It will capture the sound field at 360 degrees above and below the speaker even, and then generate it in the report format that I'm about to show you. Now, we're on my website. I'll drop this in the link below. Here's a picture. The CEA 2034 data, the thing that stands out to me, I mean, yeah, you've got really great on-axis linearity. I mean, everything about this looks really, really good. Sensitivity, I think, is around 84.5 dB on axis. But let's go look down here at the directivity index and look how smooth this is. I mean, this is one of the smoothest, and it might be the smoothest directivity index results that I've seen to date. It's just incredibly well maintained. I mean, there's a slight variation in this 1.5 to 2.5 kilohertz region. And I mean, you are picking nits to the nth degree when you're looking at that. This is just a superb performing speaker. Anechoically, objectively, and subjectively, it just sounds great. The off-axis response is really well maintained. And the vertical response off-axis, again, is also very well maintained. So let's talk a little bit about that. So here we are at the horizontal off-axis response, and you can see that, I mean, the trends here just follow on axis extremely well. Very good things that I'm seeing here with regard to the off-axis response. And the vertical response here is pretty well maintained. The point of note here, and this is really key for if you're going to have guests over and you've got a multi-tiered stage to watch movies in your movie or your home theater room with, that is to make sure that no one is too far off the tweeter axis, certainly above the tweeter axis. And what I'm seeing here is if you want to use these as surrounds, that would work great. Sit below the tweeter axis, maybe 10 or 20 degrees, and you're still okay. And the reason I'm saying that is because I'm looking at these dashed lines here. All these dashed lines, even out to 30 degrees dashed, I mean, looks really good. And we just got a general fall off in SPL, so it's not bad. But if you go above the tweeter line, then you start getting a pretty significant suck out around 1 kilohertz. So just don't go above the tweeter line. If you're going to have them as your mains with subwoofers, again, make sure they're positioned so you, the primary listener, are at the tweeter line. And if you can, make sure that the people behind you, well, they're going to have to be above the tweeter line, aren't they? Yeah, so you may want to try to use some, let's see what kind of absorption we can use to help with that. Is that from the ceiling or the floor? Ceiling bounce, there's a null there. Floor bounce, there's a bump there. So the ceiling bounce. All right. So this says that if you were to put some absorption at the ceiling to help absorb some of that 1 kilohertz energy, that would probably go a long way toward giving your guests a good overall pleasing sound, similar to what you're hearing at the main seated position. So that's kind of cool. And that's one reason why this graphic is pretty good to have on hand, although I don't often look at it. So now I want to talk about the radiation pattern of the speaker. And what I'm seeing here is a nominally, I mean, it's not very wide, but it's reasonably wide. I'd say it's about the same width horizontally as some of the KEF speakers that I've listened to, which I never really consider them wide, but they're not super narrow either. To me, very wide would probably be about this plus or minus 60, plus or minus 70 region and beyond. This speaker is going to need a little bit more toe in, but the good thing is that it behaves as well off axis as it does on axis. It's just that stereo width may be affected more by your toe end than some other speakers that are very wide. So for example, a dome tweeter on a flat baffle without a waveguide is going to have a more omnidirectional sound, but more than likely it's not going to have as good uniformity off axis. So that's one of your trade-offs, generally speaking. Vertically, what we see is the pattern is pretty narrow actually. And I'm used to seeing speakers that have plus or minus 50 degrees radiation pattern. And, you know, there's always some deviance there based on the crossover region. And this really is not any different in that regard. You do have a bit of a suck out, but it's a pretty steep suck out. And that's the same thing we talked about with the vertical off axis response earlier, where I said that using some kind of absorption on your ceiling would help with that. Same story there. Now, how does that work? So let's go back to the mid tweeter array and let's go look at some data. Near field response data. Now this black line represents the anechoic on axis. And then what I did was I put the microphone about maybe this far from each of the components. I actually opened it up. I disconnected all the components and measured them one at a time to see what the influence was or contribution was from each of the components into the higher frequency response. And then I did the same thing for the midwoofer as well. So let's start with the midwoofer. The midwoofer plays from low frequency to about 1 kilohertz. There's a crossover there. The tweeter is the blue line. And that plays pretty broad range, actually. But the cool thing about the tweeter, number one, it's 1.1 inch dome tweeter, so that helps. But it's also horn loaded in this waveguide, so that helps boost up the low end naturally. So you can give it a little bit more power than you might otherwise give a tweeter on a flat baffle. But they've used a correction circuit to kind of filter that down. So the fact that it goes low in response shouldn't necessarily scare you too badly because, again, it's horn loaded. So it boosts that low end just a little bit, gives a little bit more sensitivity, and then they're chopping it back off. So that's okay. That's reasonable. The mid-range. Now, this is both mid-ranges measured on axis at the tweeter axis. And I just wanted to see what the contribution there was. And it's really not a lot. It's actually really quite surprising. So in some way, what it seems like is the mid-range is there to help the tweeter. And I would almost consider this, instead of a 3-way design, I would maybe even consider it like a 2.5-way design or something, or maybe a 3.5-way. I don't know, 2.5-way. And I say that because, again, the tweeter and the mid-range have some overlap there, and the mid-range doesn't cover a whole lot of energy. It's just really restricted right here. And not only does the mid-range help to kind of fill in the tweeter area, but it also serves to act as a guide, a radiation beam steering array, where the tweeter might be more omnidirectional at lower frequencies, but having these two mid-ranges so far offset, their center-to-center spacing is about 4 inches, I believe, which equates to about 1 kilohertz. Let me double check my math here. Yeah, that checks out. So the half wavelength of this center-to-center distance is 1687.5. That's give or take, and that's in hertz, which means that the quarter wavelength for the lobing calculation is going to be around, what is that, like 850 or so, again, give or take. And that works out well because the beaming of the mid-woofer is starting to come into play at around 1 kilohertz. So the beaming of the woofer starts to get narrower and narrower. Then you've got this tweeter. If a typical 2-way was used, the tweeter will be omnidirectional. That wouldn't match good in directivity. But now you've got these two mid-ranges so far offset vertically that they start to narrow up more closely around the 1 kilohertz region. And so they fill in that gap of the mid-range, but they also match the directivity pattern of the mid-woofer. And that's kind of in a simple term. If the folks from Perlisten want to come on my channel and explain it a little bit better, which I'm certainly sure that they could, I welcome them to do so. But yeah, in doing so, you wind up with this radiation pattern that I just showed you above right here. And normally where you would have plus or minus 50, you've got a more restricted vertical coverage pattern, which works out to mean that you do have more predictable response in your room. And I do wonder if that vertical coverage pattern being more narrow and having less interaction with the room resulted in what I heard in the mid-range having that really just great detail. I don't know that it was, but I'm telling you, it was in that 1 to 4 kilohertz region is where I started hearing things in the soundstage that I'd never heard before. And one example was Matchbox 20's Real World. There's a snare hit, and you could actually hear the reverb off the back wall. And my wife listened to the speakers, and I said, "Did you hear that?" She was like, "Yeah, I think I did." You know, I rewound it and listened to it a couple more times, and I was like, "Man, I don't think I've ever heard that." So I went and actually got another set of speakers that I had on hand. I listened to it with those. I didn't hear it. I mean, I heard it now that I was listening for it, but not in the detail that I heard it with the Perlisten. And I went and listened to headphones, and again, you know, I kind of heard it, but not with the same detail. I thought maybe it was a frequency response thing, but my gut just kind of says, with the one thing that is so different about these speakers being that they had that very narrow vertical coverage pattern, I can't help but think that that's what I was hearing. And that's what gives these that mid-range quality that is unlike anything I've ever heard in my life. So, you know, take that for what it's worth. It's purely subjective, but it's just a little bit of information that you may find useful. Now, looking at the impedance, we can see that, yeah, we do hit around or just below 4 ohms. This speaker is not going to be an easy one to draw because it is a low ohm rating, and it also has a lower sensitivity, I mean a mid to lower sensitivity. Now let's talk about the on-axis linearity. Now this is telling me that the sensitivity is at about 84.5 dB overall from 300 hertz to 3 kilohertz. And what I do is I build a window around that. The gray is the plus or minus 1.5 dB, and the blue is the plus minus 3 dB window. And we see that we're actually really good within this window until just above 10 kilohertz. I'm not sure what's causing that, if that's a geometry thing or if there's something else going on there. But I got to say that it wasn't anything that I noticed as an issue. I did actually measure the speaker twice to make sure that that wasn't just an error in the measurement as far as, you know, number of measurement points. So I think I remeasured this with like 2,800 or 3,000 points just to make sure, and the fitting error was way below where it needed to be for that high of a frequency. So I'm confident that the result is correct. The F3 is 78 hertz. So, okay. The F10 is 40 hertz. I mean, it's a sealed enclosure, and that's the good thing about this being a sealed enclosure. You actually put it up near a wall. You can get some boundary reinforcement. The ability for this speaker to get loud, certainly there. Audibly, I was listening to Dire Straits' Money for Nothing at about 100 dB at about 3.5 meters away, which is pretty far. And that's when I started to hear the woofer pop. You know, it was being driven too hard. But other than that, you know, I really didn't have any issues with the speaker. And if you use a crossover on them, that'll take care of the woofer pop, so you can get them a little bit louder. At 86 dB at 1 meter, the distortion is below negative 50 dB, which is less than 1%. And then if we go up to 96 dB at 1 meter, the distortion is still below 1% above 100 hertz. So this speaker, again, has no problem getting loud and staying low distortion. Response linearity driven at different output levels from 76 dB up to 102 dB. Even at 102 dB, it's no more than about a half a dB variation. I'll take that. That's pretty dang good. Even some of the high sensitivity speakers, like the clipped horn speakers, they don't look this good. So that does it for this review. Subjectively, one of the best, no, probably the best mid-range I think I've heard to date. I would really have to do some A/B blind testing between this and the Dutch & Dutch 8C to see which one I like the most, because they're both just incredible speakers. They're really different in their target audience though, so I'm not necessarily telling you to go out and compare them. I'm just telling you from what I recall, those are the two best speakers that I've heard, I think, to date. To me, just the mid-range of the Perlisten S4b was incredible, and would be the one reason, if for no other reason, that would be the one reason why I would encourage somebody to demo these speakers and check them out. Make sure you use a subwoofer, and that's it. I appreciate you watching. And if you're interested in supporting this channel, I've got a Patreon. It's patreon.com/Erin's Audio Corner. Check that out. Oh, and please don't forget to subscribe if you haven't already. Okay, for real. Talk to y'all later.